This pizza box has two completely different CPUs. A DX266 running DOS and a PowerPC 601 running Mac OS. Today we're going to have some fun with the weirdest little machine from the 90s. Unfortunately, the display I'm using with it has a very nasty cataract issue. This has been a common fault on older displays from the 70s, but as time goes on, it now also seems to appear on newer displays too, like this super fancy Sony Trinitron GDM20E01. Many displays like this Apple branded Sony here have a thin sheet of glass glued directly to the tube, and what seems to happen is that the glue in between dries up, and you can clearly see when that glue has dried up. Now luckily it's just out on the edges here, so the display is still perfectly usable, but if I'm not mistaken this is just gonna get worse. Let me remove this bezel here for a better view, and we'll try to fix it. Normally I would turn the display upside down and then remove the back cover, but this beast here comes apart standing up on its stand. So we can just go ahead and remove the 4 screws at the back. And my usual disclaimer, of course, please don't mess around inside CRT displays. They could be charged with high voltages, even with the cord unplugged. This display, by the way, is an absolute monster. It's incredibly large and heavy. I got this display years ago, very cheap, but also very trash-picked. So it was completely filled up with spiders. So we have actually restored it in a previous 6100 video. I'll put a link to that video at the end of this video if you want to watch it too. And that is also the video where we restored the 6100. This display, by the way, was so disgusting. I considered taking it back to e-waste because it was so smelly, but luckily I didn't, because I put the damn thing in the shower and washed it, and now it smells super clean. It also seems to have a very low mileage, because there wasn't much soot inside, and the image is perfect. Well, except for the cataract issue. Actually, I just realized something here. Maybe we don't need to remove that shield, because there are 2 screws on each corner. So I actually think we can remove the front bezel without removing the tube from the rest of the display. I'll undo these smaller screws and we'll see if it will come off. Okay, it was actually the opposite. The large screws are holding the front bezel to the frame, and these small screws are holding the tube to the frame. Normally you would only have 1 screw here, so this is pretty neat. Okay, so I moved in real close here. So now you can clearly see that the resin has started to dry up all the way around the display out at the edge here. And on a couple of spots it has moved in to the visible area. So the way to fix this is to heat this panel up until the resin gets soft, and then remove the outermost sheet of glass here. But that is a really risky process, and it can go wrong, horribly wrong. And eventually I will probably do that if it gets worse, but today I just want to try out a simple idea I have on a possible solution to this issue. So I went online and bought some UV Loca glue. This is resin that is cured by using a UV light. And the idea here, of course, is to try to use a syringe and see if I can get some fresh resin in those air pockets. So I dipped the needle in the resin and then pulled up. And I was expecting the needle to suck the resin in, but it's not. Well, I guess we could try to fill the needle up with resin from the other side. Okay, so apparently this part here is not removable. So I'm gonna have to try to get the resin in this way here. Or I suppose we could just put the needle, because it's a standard thread. So perhaps this will work. So normally you would buy one of these separately, but I wasn't expecting to try this out, so I don't have it. Well, maybe we can use this one. It is too small, but this might work. So let's press and see if the resin will come out. Well, it actually does. Very, very slowly. But this is actually working. Okay, so we're good for a test. Okay, so let's start with this spot here that isn't visible in the image. Try this crazy experiment. So this sheet of glass is about perhaps 2.5 millimeters thick, and behind it is a really thick layer of resin. So I'm gonna try to poke through the resin here. Okay, so the resin was actually really soft, so that needle just went right through. Now let's press and see if we can get some fresh resin inside here. Oh, that actually totally worked. Maybe this wasn't too crazy of an idea after all. That spot is now barely visible. Okay, next I'm going to grab the UV lamp. And then I'm going to cure it for 5 minutes. Okay, the glue has been curing for 5 minutes now. Let's take a look. Well, with a massive magnification, I can actually see some tiny bubbles here. But without the magnification, I can't actually see those bubbles. So that wasn't really conclusive. Is this working or not? Well, if nothing else, this is a really fun experiment. Well, since that wasn't really conclusive, let's try one more spot that isn't visible in the image. And the air seems to have found its way into the resin, close to these metal brackets here. So just like the previous air bubble, this one has one on each side here. Push that syringe in and push some resin into that air bubble. Okay, I think that worked. Well, we still don't know if it's good enough. I can say for sure it's a massive improvement. So the question is it good enough? Now this added resin can also be removed in the same way as the original resin, just by heating it up to 150 C. Well, I can't see it with my naked eye, but if I look at the preview screen, I can see some bubbles. So I wonder if that can be fixed somehow. Let's push some more resin in and see if that will push the air bubbles out. Yeah, I can actually see those air bubbles move. Hope that was visible on camera too. This is one of the craziest things I ever tried on a vintage computer so far. Injecting resin into a CRT display. Okay, so by adding more resin, I got most of the bubbles out. But I can still see some on the preview screen. So let's add some more. Now I think that's the best we can do here. So I'll cure this with a UV lamp and we'll check again. Okay, the resin has cured and it's kind of the same thing here. Well, it's a massive magnification on the preview screen. I can see some tiny bubbles here. But without the magnification, I can't really see them. So not quite conclusive here. But I think we should move on and try this on a spot that is visible. Okay, so here's the left side of the display. This part here and further down here, the resin has dried up in the visible area. So let's see how good we can get this. Okay, here goes. Now we're not really taking a massive risk here. All we're doing here is to just add some fresh resin. Okay, I ran into a small problem here. I got some old resin inside the needle, but apparently that was an easy fix. Just used my rework station to heat the needle up, and that old resin got soft and came out. So let's try some more. Actually, now it went a little bit easier, so maybe that was a good idea to heat the needle up. Oh, I just realized you can barely see the difference with the lights on. So, but this part here has been filled up with resin. And this part here obviously not. So I'll try to do this without my lights on. Well, the needle keeps getting jammed with old resin. And I guess I'll just keep heating it up. Well, this was actually really difficult to get on camera. So I'll pause here and show you from a different angle. So here's that dried up resin, and this line went up this way like so, And as you can see, this whole area here is now good. So with the lights on, it's harder for you guys to see. But with the lights off, it's much harder for me to see. Well, the resin keeps getting stuck in the needle, so I'll just keep reheating it. Well, if I had known what we have seen so far, I would have bought a much nicer syringe. This tiny thing is painful to work with. Well, this tiny little bubble here turned out to be really difficult to remove. And that kind of makes sense, because that air has nowhere to go. Well, it is getting smaller and smaller, and a tiny syringe was a really bad choice, because I have to press so hard. It's really painful. Okay, finally that air bubble is moving. And it's gone. Okay, so this is totally working. I'm not sure I should bother with these tiny bubbles here, because they're only visible with the magnification. If I look directly on the screen, they are invisible. I'm not sure how much magnifications you guys have with this camera, but it is massive. Those bubbles can't be larger than a fraction of a millimeter. This is really difficult to show on camera because of all the reflections on the glass. But I have successfully filled up this entire area here with resin. And it's actually good enough so I can't even see the repair. So this is totally working. I'm super happy with the result. It looks great. Well, I guess if you try every crazy idea you get, eventually something will actually work and turn out to be an epic repair. I will show you a side-by-side comparison in a minute. But I also have this spot here to repair. It's kind of hard to see because this oily surface here is actually not air pockets. I think this is plasticizer that has come off the bezel. But this part here is an air pocket. Unfortunately, I ran out of resin here. So the dispenser I got had 5 milliliters. And that was enough to fix a 1 by 5 centimeter spot. So if you attempt this crazy repair, you're going to need 1 milliliter per square centimeter. I've actually already ordered a large dispenser with 50 grams. Because aside from those two visible spots, well, one visible spot, because we have fixed one of them, this tube also has large air pockets up here that are creeping down and will eventually reach the visible area here. So I might as well fix them before it gets worse. Now that we know how to fix it, actually if I crank up the ISO on my camera, it's much easier to see the difference. So this is the air pocket, and this stuff up here is plasticizer stuck to the glass. So we've got two completely different issues here. Okay, here's a good spot to test on. So down here we've got an air pocket, and up here we've got some plasticizer stuck to the glass. Let's start with some Windex and a microfiber cloth. No, that didn't make a difference at all. Let's try with some IPA. No difference whatsoever. It's really difficult to get on camera because these oily spots are only visible from certain angles. Okay, next I'm gonna try some Windex and a magic eraser. No difference whatsoever. Let's try with IPA and a magic eraser. Oh, that is noisy. I'm gonna have to turn the sound off here. No improvement whatsoever. So how the heck do we get this stuff off? Okay, let's try something smelly. So white vinegar and baking soda. I'm skipping ahead here, of course, but I'll try this for about 30 seconds. Okay, let's wipe that smelly, messy stuff off. No difference whatsoever. Man, this stuff was really hard to get off. Okay, in that case, I'm not sure how to get this stuff off. If anyone watching this knows how to get this stuff off the glass, then please leave a comment. We'll try some more in a follow-up video. Well, it's not on the inside, because if I look from the side, I can clearly see that the air pocket is on the inside of the glass sheet. And this oily substance here is on the outside. So there must be a fix for this, but unfortunately I don't know how to get that stuff off. I'm not 100% sure, but I think it's plasticizer that has come off the plastic bezel. I reinstalled the bezel, so now we can do a side-by-side comparison. And there isn't really anything to show here, because the nasty cataract that was here earlier, it's completely gone. There might still be some microscopic air bubbles, but nothing visible to the naked eye. So that was a mega successful repair to a fault that I didn't think we could fix. Those oily spots, by the way, they are not visible under normal lighting conditions. They're only visible when I have some very strong direct lights shining on the tube. So when doing some retro gaming under normal lighting conditions, those spots are not visible. But I do want to fix them anyways. So leave your thoughts and we'll try something in a follow-up video. Unfortunately, the original hard drive started to make some really awful high-pitched noises. So I swapped it for a blue SCSI with a blank image on an SD card. But when I try to install macOS, it just keeps crashing. So I think we may have a fault with the CD-ROM drive in this machine. Let's take a look inside and see if we can fix it. So first I think we need to manually eject the drive. Actually, this drive required something very long to eject the drive. And then we need to push these tabs all the way around to get the whole front panel off. By the way, this is a Sony CDU55S-25, manufactured in December of 1994. So very likely the original CD-ROM drive. Okay, let's see if we can remove this lid next. That reveals a couple of more screws on the PCB. Okay, let's try to remove the PCB next. Oh, I see. I think we need to turn it around and pull this lid off first. Okay, very nice and clean inside here. I'm not 100% sure because I have restored many 6100s, but I think this was the machine that came looking pretty much brand new inside. It came from a library. So apparently that library bought this machine and forgot to use it. Okay, I think we need to push on this tab next. Then this tab here. I have repaired many CD-ROM drives. They're all slightly different. Okay, so now we can flip the PCB out. And inside here we have all the fragile flatX cables. They are disconnected by pulling on a small lid. And then they can be pulled out. Well, I did a proper visual inspection of the entire drive, but I can't see anything obviously suspicious. I was expecting we would find electrolytes all over this board here, but that's not the case. These caps have actually not started to leak yet, but that is of course a question of when and not if. The drive is partially working, but when I try to install macOS, it just keeps crashing. Sometimes it runs for a couple of minutes, and sometimes it almost finished the installation. So we're gonna have to guess here, and I'm gonna place my bets on one of these caps here being marginal. And since these nasty little buggers are planning to leak and destroy this board, we might as well replace them and see if that fixes the drive. Okay, I went through my stash and I found all the caps. And here's my crappy cap list if you need it. So basically you need 3 caps that are 4716, 4 caps that are 1016, one 4.7 micro 35 volt cap, and 6 of these 22 micro 16 volt caps. I like to start by making a mark on all the caps before I start. That way I know for sure I haven't missed one. Next I check if any of the caps are bipolar. It's so easy to miss it, so I always like to check and make sure. On this board we don't have any bipolar caps at all, but it is a very common thing to find in a CD-ROM drive. Next I check the polarity markings on the board, because sometimes it's missing, and occasionally it's actually incorrect too. The final thing I do before I start is to take a high-res picture of the board, just in case something is unclear later when it's time to replace the caps. Then I'm going to place one blob of solder on each tip and start removing these dried up caps. I love my tweezers. It makes the recap so easy. This is the best tool I have acquired in years. It takes about 5 to 10 seconds to remove each cap. And I keep reapplying some fresh solder to the tips occasionally. Okay, I got some fishy smell when I removed this cap here. So that cap is very likely the reason why this drive is glitchy. And as always, I'm pulling the cap off sideways. I never lift the cap off the board, because if it's slightly stuck, it will rip one of the pads off. So that is super important. By the way, I was experimenting with different temperatures in the unboxing video of this tool. And since then I have pretty much settled at 400 C for electrolytic SMD caps. It's slightly too much heat, so they will pop occasionally, but it's also much quicker than going for 360 or 380. So it's kind of worth an occasional popping cap. I have also tried with the temperature maxed out at, I think it was 500. And that of course made for a very quick recap, but it also destroyed the tips very quickly. So I had to replace them. Next I'll add a little bit of flux on all the pads. And then I'll clean the pads with some wick. And the final step is to clean the flux up with some IPA on a Q-tip. Since this board looks pretty much brand new, I'm going to clean that flux up very thoroughly and skip the bath afterwards. I switch to my large curved tip, because I'm going to need it on some of the caps. And I'll place a blob of solder on one of the pads. And C602 here is a 47 micro 16 volt cap. So let's reflow that solder and install the cap. And then I can solder the other side of the cap. Okay, I installed the remaining caps and reassembled the CD-ROM drive. And now I'm installing an OS from the CD-ROM drive. We could easily have pre-installed it on the SD card, but this is a good stress test of the CD-ROM drive. Let's see if those dried up caps were causing the issues. Okay, and that totally fixed it. So those were just some dried up old caps. And the CD-ROM drive works perfectly. Okay, our next issue is the nasty flickering here. Now, this is not actually the display flickering. This is a mismatch between the refresh rate of the display and the camera. And that is because I only have 67 and 75 Hz to choose from. But the camera needs 60 or 80. Well, I found this app here online, SwitchRes2. Let's give it a try. Well, I kind of sort of almost found a solution to this, but not quite. So I wasn't able to make SetRes2 work at all. It just hanged the system. So unfortunately it seems to be incompatible with this machine. But then I found an older version, SetRes1, and it worked, but I can only choose between the two options we already had. So that software was kind of useless. So then I did some reading, and apparently by grounding some pins, the display is telling the system what resolutions to make available. So I went through my stash and I found this adapter here. This adapter here has two switch blocks, and by changing the switches here I was able to set the cable to pretend that this monitor is running at 60 Hz at 640 by 480. So now we only have one option here, and that is of course 640 by 480 at 60 Hz, which is perfect for YouTubing. And as you can see, the display is perfectly flicker free. But then I ran into a new problem, because this adapter here is turning the DE15 to regular VGA connector. So it's basically designed to use a PC display on a Macintosh. So I went through my stash again and I found this adapter here. And it fits, and it's clearly marked Mac adapter and a very long number. But unfortunately it wouldn't work. I also tried the Apple display with the regular PC and this adapter, but that wouldn't work either. So unfortunately I think this adapter removes one or more connections that is required for the Apple display to turn on. So I can use this Mac with the PC display now, perfectly flicker free, but not on the matching Apple display. So that is super annoying. And as you may have guessed by now, the plan for this project is to use both of these displays with this Mac. It's a bit hard to find reliable information online, but as far as I can tell, these two displays are both Sony displays. Probably Sony GDM SE1 or SE2, or quite possibly GDM20 EO1. Unfortunately, I wasn't able to find any information about this adapter online. I wasn't even able to find a pinout to go from PC to Mac, but hopefully someone watching this knows how this adapter should be hooked up and will let us all know. And if I can't find an adapter, I can just make one. It's a pretty simple thing here. I suspect that it's just missing one or two connections in between here that we might be able to add into this adapter here. But unfortunately at the moment I don't have the information on what's missing or wrong here. Okay, our next issue with this weird and wonderful Mac is to connect the display to the DX266 part of this machine. Unfortunately, that requires an equally weird and wonderful cable from Apple. And that cable is really hard to find, and when they occasionally pop up on eBay, they are super expensive. That cable costs more than I paid for this entire machine. But luckily my favorite sponsor, PCB got us covered, because someone has designed some PCBs to solve this issue. I think I found this project on a forum thread. I'll check and put some information on the screen here. So basically someone has figured out the pinouts of that weird and wonderful cable and made this adapter board. And all we need to do is to install a bunch of connectors here. So this should be a pretty easy project. Okay, so this one should be quite obvious because it has 3 rows of pins. And these two are marked F15. So presumably female DE15. And the last one here is marked M15. So presumably a male DE15. And I think that's all there is to it. I'll start by soldering 2 of the pins on each connector. And then I'll check and make sure that the connectors are straight and flush to the board before I solder the remaining pins. Because it's so much easier to adjust them if needed with just 2 pins soldered. And they totally are, and that is because they are snap-in. So the connectors are held in place with these tabs here while you solder it. So now we can solder the remaining pins. I love projects like this. Without this PCB, this project would have been really expensive. I'm not sure why Apple went with that weird cable, but I guess there wasn't room enough for all those connectors at the back of the DX266 card. Okay, all the pins are soldered. Let's clean this mess up. Okay, nice and clean. These 2 snap-in tabs here are actually missing solder pads. So if you've got some KiCad skills, you may want to add them before you order your PCBs. And if not, you just have to be a bit careful and not put too much strain on this connector here. Oh, okay, it's done. Let's try it out. The PCB is actually clearly marked here, so this connector here goes to the display. This connector is for the joystick. This one goes into the DOS card. This one connects to the Mac. To make the adapter complete, I also got this short cable here that connects to the DOS card. And the connector marked the DOS card. Okay, the contraption is connected to the Mac. And this Mac has a weird and wonderful HD45, I think it's called. So first it has an adapter to the adapter, and then it has a cable going back into the Mac, connected to the DOS card. And then the display is connected on this side here. This connector is for the joystick. For the sake of the video, I'll use that switch block thingy and connect it to a regular PC display. I had a look on YouTube, but I actually couldn't find any information on how to make this work. So I guess I'll include it in this video. So the first thing we need to do is to go to Apple System Profiler, and under Devices and Volumes we can check and make sure here that the DX266 card is recognized, and it is. So here we have Macintosh PC DOS card. So all good so far. And the next thing I had to do was to install StuffIt Deluxe 5.5, because my regular StuffIt couldn't uncompress one of the files we're going to need. And then I went online and downloaded the diskettes that were included with this card. And then I used Basilisk 2 to uncompress the file. And then I used HFV Explorer to make real floppies of the software. So now we have real floppies. And the first floppy we need to run is the Mac installer. Okay, so I spent some time looking for diskette images for the PC configuration tool. And it turned out to be included in macOS 8.6. So that was some wasted time. It's down here in the list. PC setup. Okay, so let's configure the card. Okay, so I'm guessing here, but I'm gonna say we probably need new drive file. Create new C drive as... Okay, let's just call it PC HDD. Let's make it 500 megs. And down here we have the option of initializing the file. Not sure if that means partitioning, but let's try this. I think it's working. Okay, and it just disappeared, so I guess it's done. So, question is, do we need to make a partition or not? Okay, so I've got a DOS diskette in the drive, so let's start the PC. Starting MS-DOS. Awesome, so it's reading from the diskette. So let's see if we can install it. Yeah, I think this is totally working. Awesome, so I'll skip ahead here a bit. Okay, it ran through all 3 diskettes. And since the Mac doesn't have an eject button, I used Command E to eject the diskette. And we can press enter and enter again. It's counting up the RAM, and we've got a 16 meg stick on the DOS card. And it boots, awesome. Wow, okay, so if you go with macOS 8.6, setting up this machine is super easy. And now we can switch back and forth with Command enter. So now it's a Mac. And now it's a PC. This machine is magic. Okay, I installed some Monkey Island here, and it's running perfectly. It seems to be a pretty decent DOS machine. It has its own RAM, and it also shares the level 2 cache with the Mac. So pretty decent performance. But we're not quite done yet. You guys know me, we are of course going to overclock the crap out of this machine. When that video is out, I'll put a link on the screen here and down in the description. Before you leave, like, subscribe, and consider joining me on Patreon. Thank you for watching, and I'll see you guys again next week.